Hey everybody, so in this video we are going to determine the number of all possible rational zeros, then we're going to find the zeros. They also want us to use Descartes' rule of signs here to help you eliminate possibilities. So in order to list all the possible rational zeros, we need to take the factors of 4 and divide it by the factors of 2. That's our rational root theorem. So you may have seen this notation, P divided by Q. P is going to be all the factors of 4. So all the factors of 4, this would be plus or minus 1, plus or minus 2, plus or minus 4. And we'll take these and we'll divide them by all the factors of 2, which is plus or minus 1, plus or minus 2. So to find all your possibilities, you're going to take each factor of 4 and divide it by each factor of 2. So 1 divided by 1 is going to give me 1. 2 divided by 1 is going to give me 2. And 4 divided by 1 is going to give me 4. Now we'll say 1 divided by 2, that's going to give us plus or minus 1/2. 2 divided by 2 is 1, but we've already accounted for that here. And then 4 divided by 2 is 2, and we've already accounted for that here. So these are all of my possible zeros here. Now, they ask us to use Descartes' rule of signs to help you eliminate possibilities. So Descartes' rule of signs says that you are looking for the number of sign changes here. So if I start at positive 2 and go to positive 15, there's no sign change, no sign change, no sign change, no sign change. So that means that in regards to the number of positive solutions, there are none. So that helps us eliminate the numbers that we could substitute in using synthetic division, because there's no reason to plug in positive 1, 2, 4, or positive 1/2. All of my solutions are going to be negative. So I could start with negative 1, negative 2, negative 4, or I could start with negative 1/2. So if I'm doing my synthetic substitution, let's start with negative 2 here. Now, if you do not want to play the guessing game, if you don't want to try to go through and guess negative 1, negative 2, negative 4, or negative 1/2, you could always plug this into the calculator to give you one root. So I'll go ahead and type this in here. Okay, now that I have this typed in, I'll look at my table. And I see that I have a root here at negative 2. So for my synthetic division, I'll evaluate at negative 2. And I have to use the coefficients here from this problem. So that's going to be 2, 15, 31, 20, and 4. First term always comes down. Negative 2 times 2 is negative 4. This gives me 11. That gives me negative 22, which is 9. This gives me negative 18, which is 2, and this gives me negative 4, which makes that 0. So here, if I'm talking about my factors, remember, if if negative 2 is a root, then x plus 2 is a factor. Your answer to synthetic division, these are your variables, but remember that the leading degree is decreased by 1. So this will now be 2x to the third plus 11x squared plus 9x plus 2. Now, looking at this, there's not a way that we can factor this. With 4 terms, we think factor by grouping, but that's not going to work here because you're not going to get like binomials. So we're going to have to use another root, and we're going to have to use synthetic division again. So if I go back to my calculator and I go to the graph, see, we've already used -2 here, which out of our list would make that -1/2. So this is not -4, right? This looks to be like maybe -4.5. But since this looks to be -1/2, we'll try it. So I'll use my synthetic substitution at -1/2. And then I'll use the coefficients from this polynomial here. So that would be 2, 11, 9, and 2. First term comes down. This is going to give me -1. Now I have, when I multiply, -5, and when I multiply I get -2 and 0. So -1/2 is going to be one of the solutions. So now when I write out my factors, I have x plus 2, x plus 1/2, and now remember that your degree decreases by 1. So this started with x cubed, now this will be x squared. 2x squared plus 10x plus 4. Now, in order to find the zeros, we are going to have to set each one of these equal to 0. So we already know this is going to be -2 and -1/2. Here, we need to think, is this factorable? Well, I know I can pull out a greatest common factor of 2. So each of these divides. So that would be x squared plus 5x plus 2. And I need to think, are there two numbers that multiply to give me 2, and when I combine them, I get 5? And that answer is no. So this is not factorable. So here we're going to have to use quadratic formula in order to find our next set of solutions. So I'll go ahead and do that down here. That's going to be -b. We can keep these values the same, so we could say -10 plus or minus the square root of b squared, so that's 10 squared minus 4 times a times c, and this will all be over 2a. So when I reduce here, I get -10 plus or minus the square root 100. -4 times 2 is 8. 8 times 4 is 32. So 100 minus 32 is 68. And this will all be over 4. So this will work as your solution. Remember, you only have to simplify if your professor or teacher has that as a preference. So let's come over here and write our solutions. So x is going to equal -2, -1/2, and x is going to equal -10 plus or minus root 68 all over 4. All right, that's going to be all for this example. I hope you found this video helpful. If you have any questions, please be sure to leave them in the comments.